Okay. This is a UV light, ultraviolet light. It's basically a fluorescent lamp that they take the fluorescent coating off inside here and charge you more for it. I haven't installed it. This is an upper room UVGI device. It would typically be in a facility at the high level, mounted on the wall. In your facilities, have you seen these round things that emit a blue glow? Okay. It's the same thing as this. Those are what they call pendant UVGI devices. This is a wall-mounted one. That UV is such a low penetration ability. It won't penetrate the fingerprint to hit the reflective surface. So if you leave fingerprints over this thing, you effectively leave little opaque patches all over the device. Don't touch the lamp, the same thing will happen. You're basically painting that lamp with fingerprints. You'll reduce the effectivity of the whole device.
If I would like to install the lamp, can I use a tissue or
gloves? Just wear gloves. Just wear gloves. It's fine. You just don't want to leave your greasy fingerprints all over it.
Yeah. Okay. And if I don't have gloves?
Get gloves. I mean, what do these things cost? $12. It's not even $1. No, get gloves. You've got to work with gloves to protect your hands as well. There's a lot of sharp surfaces here. You don't want to injury on duty. Definitely don't want to bleed in the lamp. Please. Okay, it's very simple. Give it a dusting, give it a cleaning. Some of the manufacturers are going to sell you a special tool, which is basically a spatula with a cloth on it, which does make it very easy to get in de-dust in between all those things. Get all the bugs out. Sometimes you'll find moths and things like get attracted to the blue light, so you might want to vacuum it out as well. Very simple. So you give it an initial cleaning, slam the light closed, and then you're going to take your UV meter and take a measurement of the device. The acceptance criteria, I can't tell you what it is because it's dependent on the device. Okay. Every device has got the manufacturer is going to give you a data sheet, and it's going to say that at a 1 meter measurement, taken horizontally, the maximum measurement of the device has got to be, let's say, 100 milliwatts or something like that. Depends on the device. So you will measure to make sure that you're not getting less than 70% of that measurement. If you're within 70%, you're done. If it's fallen lower than 70%, you might want to try and give it a bit of a better clean. You might want to take the lamp out, clean it a little bit better, see if you can get it up. If you can't get that measurement up, it might be time to replace the lamp. If replacing the lamp doesn't help, you might want to replace the ballast. But beyond that, you're going to get it going again. Even your devices in your facilities that aren't working now, replacing lamps, replacing ballasts will get them going again. Basic maintenance. If I come to a device I don't know if I've covered this already. If I come to my devices in my facility, how can I tell quickly if they're working or not? They still glow blue. So do you think they're still working?
No, with us it's because of non-maintenance. I don't think it is.
So that blue glow is just blue light. It's not UV. It's not the good stuff. UV is invisible, so you can't see it with your eyes. And in fact, the amount of blue light coming off the lamp is very, very small compared to the amount of UV. So just because you're seeing a little bit of blue glow doesn't mean that there's any UV left in the system. It's a weird way to say it. So you've got to measure it with a UV meter. This is a cheaper, nasty UV meter. It's got two different ranges, milliwatts and microwatts. So depending on whether you're measuring for eye safety or performance. We're only doing performance measurements now. What do you think this thing costs? I told you it's cheap and nasty. In rands. The thing was $12,000. And you've still got to calibrate it. 2,000 rand for calibration. So by the time I'm done,
How often?
every year. Once a year. And so you do get much better devices than this, but they cost 5-6 times as much. My recommendation is at least get something so that you can measure. Problem with this, the cheap stuff, is we want to be measuring UVC. I know there's no UVC in this room, the light's off. If I do that, it tells me I've got 0.3 microwatts. I'm typically looking somewhere when I'm measuring off this device, I'm looking in the range of 100 microwatts. So that 0.3 indicates there's noise. It's picking up UVB or UVA from these lights, I don't know what. But there's noise. But in the range that I'm measuring for performance, it's actually fine. So you don't have to spend the crazy amount of money. Waiting areas? Because we traditionally think of our waiting areas as high risk, right?
Yes.
Maybe in the actual examination rooms where you
In South Africa, in a resource limited setting, okay, you've only got so much money, you've got to spend it on the most effective thing. You can put 20 of these devices in this waiting room, plus measurement equipment, plus training, plus all the maintenance that goes with it. Each one of those lamps is 2,000 rand, you need to replace it. You're going to have to replace all of them at least every year. Some of them you might need to replace more often. It adds up. And then you think of the average person that uses that space. Average South African spends 8 hours in a healthcare facility in a year. So you're spending all that money to protect him for 8 hours of the year. Where perhaps if we'd spent that money tracking, tracing and treatment, you're getting into the community, treating him where he is and preventing transmission that way, probably a lot more effectively. So my proposal is, if we've got no UV in our facilities and we're starting an implementation plan to get UV back into our facilities, let's not start with waiting rooms. Let's look at healthcare, where our healthcare workers are exposed. Because they're not there for 8 hours a year. They're there for 8,000 hours a year. We can do much more good with UV devices in consulting rooms, places where healthcare workers are exposed to their patients for extended durations of time. And also not at the expense of dropping respirator and ventilation and so on. It's an additive to all of those other things. Okay. So definitely, in fact, it's indefensible to not put UV devices up in spaces where our healthcare workers need to be protected. We know it's effective. We know it's cost effective in those environments as well. And the regulations mandate that we must. So as a start, this is a very valuable resource for us to protect our healthcare workers. Down the line, when the Department of Health has got lots of money to spend, we can start putting them in waiting rooms and that sort of thing as well. Yeah, that's my story.
So how much does one of this cost?
I think this device is about 10,000 rand. Could be more. But then you still got to pay for installation and validation and maintenance. There might be electrical changes that need to be done to your building to get them installed and so on. So just this off the shelf is about 10,000 rand.
So I've seen the portable ones where they go into a room and then you just see flashes. Is it the same or no?
Okay. So
a patient emergency department particularly, I've seen
the patient comes into a room. So we're talking about airborne transmission for TB, right? Patient comes into a room, coughs, goes out. You bring the flashy lights in. Makes me think of Men in Black. Bring the flashy lights in, kill the TB, take the flashy lights out. Next patient comes in. Don't go bring those flashy lights back again.
Okay,
doesn't work.
Makes sense, yeah.
For airborne transmission, those flashy lights aren't useful. There are all sorts of other issues with the flashy lights. They're very difficult to reproduce the performance. You've got to put it in exactly that position. Everything in the room's got to be positioned exactly right. You've got to validate all the shading effects because it only irradiates where the light hits. What about the underside of your grip on the bed? How are you getting there? And then how do you validate? Every time you do this, you've got to validate that you've covered properly. It's much easier just to take a cloth and wipe the thing with some soap, please. Or alcohol wipe. Much more. We don't recommend the flashy lights. They've got applications in laboratories and so on where you've got very controlled conditions. Things are repeatable. You can do it over and over again. Where that sort of cabinet's installed, you might want to put a UV light inside that cabinet to do sterilization. You might put them above benches to sterilize bench surfaces. But where you've got patients and doctors and equipment moving and no 2 minutes are the same and it's chaos, it's not a good application.
Thanks.
Wash it, soap and water, alcohol wipes if you need. Install these guys.
So in cases where you're using the pendant ones, so it means that you'll need a lot more than you would this thing?
Probably not. I will say that it's a lot easier to install 20 of these along the walls than 20 pendant devices. So for a new installation, these are easier to put in. Pendant devices need structures in the ceilings to be installed. You've got to wire through the ceiling and so on. Installing them on the walls is a lot easier, a lot closer to you.
At the 7th South African TB Conference in Durban, ETTi presented Airborne IPC workshop. All lectures and exercises can be found on the ETTi website.